Welcome to this short introductory video on the Python library SLISEMAP, combining supervised dimensionality reduction with local explanations. My name is Puolamäki and I am from the University of Helsinki. Together with Anton Björklund and Mäkelä, we have developed SLISEMAP. SLISEMAP is a new supervised dimensionality reduction method that can be used to explain black box classification and regression models. SLISEMAP is open source and available as a Python library via GitHub. To understand SLISEMAP better, let's start by briefly looking at two techniques that inspired SLISEMAP. The goal of dimensionality reduction is to turn a high-dimensional dataset into a lower-dimensional embedding that preserves some of the patterns in the data. This is used for example, visualizations. Explainable artificial intelligence is the field dedicated to investigating how complex black box supervised learning models work. A local explanation is a type of explanation where we investigate particular predictions of a black box model, one at a time. A common approach is to approximate the complex model with a simpler one locally. With SLISEMAP, we combine these two by finding embedding, coordinates, and a local model for every data item, such that data items with similar models end up next to each other in the embedding. We express this as a loss function, where the losses from the local models are weighted based on the distances between embedding coordinates. This means that data items with incompatible local models get pushed far apart. And since we limit the radius of the embedding, data items with similar local models form clusters. We will look at an example of this shortly. SLISEMAP is implemented in Python using PyTorch for optimization and can be installed via pip. Using SLISEMAP requires only a couple of lines of code. The two most important are the creation of the SLISEMAP object and the optimization. The built-in plotting function returns two plots. The plot on the left is the embedding and the local models are on the right. To make the models easier to read, we have clustered them by the coefficients and shown the mean models in a bar plot. The points in the embedding are color-coded with the same clusters, showing that embedding clusters match the model clusters. To summarize, SLISEMAP is a new supervised manifold visualization method that simultaneously finds local models for every data item and constructs an embedding based on the local models. Please read our ArcSIP publication for a more in-depth treatment of SLISEMAP. And on GitHub, you can find documentation for the Python library and tutorial notebooks. Thank you for your time and interest.